You have already added. So could you share your screen, please?
Yeah. Okay. Great, we are live. Yet another episode of YFTT. So we'll give it a minute and then we'll get started. Okay, so let's get started. Welcome to YFTT, YugabyteDB Friday Tech Talk by engineers for engineers. This is episode number 102. Exciting. So I'm your host. I'm Prasad Radhakrishnan from Open Source and Community Engineering. And today with us, we have Bala. I'm going to let Bala introduce himself. And the topic today is moving data in near real time from distributed SQL to data lakehouse. So how do we make it happen? That's what Bala is going to cover. So, Bala, you want to introduce yourself?
Sure. Thank you, Prasad. Good morning, everyone. Good evening. Yeah, my name is Bala, working as a field engineer in Yugabyte, Bangalore. Yeah, thank you.
Thank you. And he's also one among the nicest humans that I have come across in my life. So, Bala, that said, let's roll. What do you have for us?
Thank you. Yeah, thank you, Prasad. Yeah, so today's topic is going to be interesting, I'm sure. It's going to talk about like how we will be moving the data in near real time from distributed SQL to data lakehouse. So like how YugabyteDB and Apache Hudi are going to talk each other, and having that story. That's where we are going to talk today on those use cases as well. So with that, I will quickly introduce to the agenda. So the agenda, we are just going to talk about the need, the use case and purpose, and what is data lakehouse. Really, this is the hot topic today, going across. A lot of enterprises are adopting this data lakehouse. And what is specifically Apache Hudi, and how quick primer on YugabyteDB. Interestingly, like people may know like what are the strong features of YugabyteDB and YugabyteDB's change data capture. And finally, we are going to talk about solution architecture, how both can talk to each other, and with a demo. Yeah, that's a short agenda. I just thought of share it. So with that, I will straight away go to the. Yeah, thank you, Prasad. Yeah, so with that, I will straight away go to the topic. So yeah, as many of you know, near real-time analytics is one of the need for your organization. So be it in any domain. So this near real-time analytics is helping you not only to take some immediate decision, but also helping you to get the data in real time to where you can take some informed decision from the app engine which is running on transaction side as well, right? So that's where if you take it like predictive maintenance for an automobile, or even real-time credit scoring for a fintech industries, even a next best action, next best offer from a retail, right? So that's how people can get their the best product from the what do you call the recommendation engines and other things. So we also have like a route optimization. What is the shortest route from logistics and e-commerce? Even there are like dynamic pricing, specific analytics are required for trading and e-commerce or advertisement domains as well. So knowing that like this is a need, like where industries are really eyeing on these sort of analytics. So where we see the diagram which is clearly right, like we have the left side the transactional DB, the right side you can see a data lakehouse. The flow always starts from an application which is posting the transaction, where the DB is taking care of those CRUD operations and doing like insert, update, delete, whatever the operations has to perform. And then the DB needs to continuously send the stream of data, and either it can be incremental or like a delta to a data lakehouse. So this where data lakehouse is really going to perform a lot of analytics and predictions based on the historical data what we collected from the transactional DB. That will be passing the predictions, maybe like a score value or maybe a recommended value back to the app. That's so app can combine the both transactional features as well as the analytics features, which is helping the customer to take the decisions on the fly and making sure that they are able to move forward with the future of both the things are talking and helping them to do the right thing with the app itself, right?
Yeah. Bala,
That's how
just to
the
quickly add some color to what you are just describing. So this is basically the scenario where traditionally we have been looking at, from transactional database, we move data over to a data warehouse or lakehouse, whatever that might be, but nightly or sometimes it's
right.
micro batches. This is even fine granular like that, where you want to constantly enrich your lakehouse. So there are, like you mentioned, there are a set of
That's
use
right.
cases that require constant enrichment of the lakehouse. So your predictions get better and better, or is more accurate to anything that is changing on the transactional database. Is that one way to put it? Oh, I think we might have some network. Sorry,
Yeah.
did it come across? I was just saying that
Yeah, go
this
ahead,
is one
please.
way constant enrichment. Yeah. Okay. So I guess either I'm frozen or Bala is frozen. Not sure.
Yeah. No,
Go ahead, Bala. Bala, can you hear me?
Looks like Bala is frozen, Prasad.
Okay.
That's
Okay,
fine.
got
Well,
it. I think. Yeah. That's not a problem. I can bring up the slides and I can actually, talk to uh,
there you go. I think he's back.
He's back.
Yeah.
Okay, not a problem. This happens.
yeah, sorry, Prasad, I don't know. Is it my end is an issue?
Yeah.
Please
I
go
think
ahead.
there's a little bit of connectivity issue on your end, but that's fine. We can keep rolling.
Yep.
So you're not sharing your screen yet, Bala?
Yeah. I'm just sharing the screen. Is it visible now?
Not yet.
Oh, okay, fine. Yeah. Please go ahead, Prasad. I just shared it. Yep.
It's loading up. So Bala, would
Bala,
you like me to?
start
Yeah,
again.
maybe. Right. So maybe I can share the screen, and then later you can get to the demo part. Is that okay?
Yep.
Okay. So let me share the screen. And at any time, you're not able to.
Sure.
So print share screen. All right. Is my slideshow coming up?
No, but Bala, you were able to share your screen.
Not
So
yet.
let's go again.
Okay. So what am I supposed to do?
Bala, can you share your screen? Yours was working. Bala, can you hear me?
Oh, Bala, can you hear us?
Yeah, I'm able to. Are you going to share
Can you
it or you want me?
No. You please share the screen.
Sure. Yeah, I will do that. I did the sharing. Yeah, please go ahead, Prasad. Is it coming up?
Prasad, you're muted.
Yeah, so I think we established the need and purpose where we are sharing. We are constantly enriching data to the Lakehouse, so we can move on to the next one.
Sure. Yeah. Thank you. Yeah. So there are lot of jargons around this data lakehouse. So, but we just want to understand. So, what is a data lakehouse in this slide? Data lakehouse is been emerged from data warehouse, where you see the traditional data warehouse, and even it is combined with the data lake. So, it is basically addresses the limitations of data lake, what you cannot do it with the data lake alone and data warehouse alone. So that's where it combines the best of breed features from both these things, and where data lakehouse is really helping to decouple the storage from the compute, and it is also supporting the streaming for eliminating the need of a separate streaming engine or a serving layer like earlier days we used to do the real-time data applications. And data lakehouse is also taking care of both our BI and the AI workload. That's where now many enterprises are started adapting data lakehouse to solve the problem in a single puzzle, that maintaining data warehouse and data lake together, right? So that's how data lakehouse is really getting adopted well, because of these sort of features are being already there. So specifically, we are going to talk about a data lakehouse. So we here in this case, we just thought of take Apache Hudi. So Apache Hudi, where it comes in the data lakehouse components. So as you can clearly see, like Apache Hudi is one of the table format, so which is typically used in HDFS or S3, like a blob store, or even a local file system. You can keep your Apache Hudi table format. So apart from that, there are other components are there which we are not touching on this demo. So we can see on the left side, like it has the storage, the different file format. We can even store it in the data lakehouse, and it is being processed with the different compute engine, and we can also store the data in different catalog like Hive or even AWS Glue or different metadata store as well, right? So many people might be asking the question, so why Apache Hudi? What is the reason this Apache Hudi? What exactly this Apache Hudi is really going to help here? Apache Hudi is stands for, it's a Hadoop upserts and deletes and incrementals. So this is where in the older days we used to do Hadoop only for append only transactions, where it is not allow us to do the upserts or deletes, all those sort of challenges we faced. So Apache Hudi comes up with the open source data management framework. It is simplifying our incremental data processing and data pipeline. So how it can bring the stream processing to big data, making sure that we are able to get the data seamlessly to the format that we want to store it. So either it is more for a read purpose or a write purpose, like it will help us to define the table format based on your workload or based on your use cases that you are going to store it here. Yeah.
So, Bala, in other words, what Hudi brings to the solution is the ability to do inserts. Not only inserts, we traditionally were able to send new data, but instead of an append only file system, which stands for append only, Hudi gives this ability to be able to update and delete records, much like what a a transactional database would offer, but in the context of analytics.
That's correct. Yep.
Awesome.
Thank you. Let me move to the next slide. So now this is the time we need to understand how Yugabyte is going to synergize with the Hudi, right? So most of you know YugabyteDB is a Postgres compatible distributed SQL database for cloud native and transactional applications. So the meaning itself says it's a data living forever without limits, right? So that's exactly what Yugabyte is going to help, bringing the data for you to keep more transactional workloads to store it in the distributed way. So here you can see we have a two-layer architecture in this diagram. So where you can see the top layer is a query layer, the bottom layer is a storage layer. So which basically helping you to query it either through Postgres-based workload or a Cassandra-based workload. The DocDB storage layer, which is transactional, and it is making sure that it takes care of sharding your data automatically and taking care of load balancing your shards automatically. And more important, it is distributed transactional DB, where you can just bring your RDBMS workload seamlessly to Yugabyte and just continue work whatever you are doing today with your RDBMS with the help of the raft consensus and all those things, where you can get the replications seamlessly, right? That's the power of YugabyteDB. The need here is, okay, we saw the first slide, like the need here is the transaction DB has to keep all the transactions coming from the applications, and it has to support the ACID property of those transactions with the specific CRUD operation which they are going to do that. And it also has to help constantly send a set of data what your data lakehouse is required. How do we ingest these incremental data in near real time to a data lakehouse, right, on the right hand side? That's exactly the need here, like how we are going to use Hudi tables to do that from YugabyteDB, right? So we are going to use YugabyteDB's change data capture. It's part of our DB engine, and it is going to help you identifying the changes and tracking the changes whatever you made in the database. Like for example, you inserted a record, or you updated a record, or a deleted record. All of these going to be identified with the specific flags where the changes are going to be captured in Yugabyte, where it continuously sending to the streams to the external process or an application which needs to propagate the changes. So like what happened in Yugabyte to the downstream sinks or an applications based on what it is written or available in our Yugabyte's write ahead log, right? That's the engine which constantly tracks those changes. YugabyteDB uses like a standard Debezium connector where it captures the row level changes, whatever resulting out of your CRUD operations. So in the upstream database, right? And then it is also publishes them as an events to your Kafka using Kafka Connect compatible connectors. So that's how
I
it's
think
very
it
simple.
means that you don't need a golden gate like connector. Sorry, just
Yep,
to say that you
that's
don't
right.
need a golden gate connector or anything proprietary to start consuming change data from Yugabyte.
Yep, that's right.
Yeah.
Yeah. So this diagram is helping you to see like what Prasad said, right? So the Kafka Connect connector, which is going to pushing those changes an upstream from YugabyteDB to Kafka as a topic where you can constantly propagate the changes. So and then you can just keep a number of topics, whatever you want to keep it with the different formats that you want to transform into your Kafka site. All those things are possible. So in this example, we taken for example an order details, so which is available in multiple tablets in the wall, where you can see that. So these tablets are being going to be processed in the Kafka Connect clusters by having multiple tasks like task 1, task 2, task 3. Like each of the tasks are going to process set of tablets, and finally it is pushing those uh, changes to the partitions what you created on the Kafka side, where it will be start storing those data into respective partitions, right? So here, fine. Here, the mapping here is your table is going to be mapped to a topic on the Kafka cluster. That's the standard way, like what Debezium is currently even doing it for other DB. We are also going to just follow the same standard here, just so that it will be easy from a adaptability perspective and deployment perspective. This is the way, like even CDC are going to move it to Kafka side. How do we integrate YugabyteDB with Apache Hudi? So there are two models we are showing here, or two flows we are showing here, right, in this architecture. Suppose I have a requirement of real-time streaming where I have a near real-time analytics use case or a real-time analytics use case where I need to constantly get those changes from YugabyteDB through Kafka, and I want to use my Hudi Delta streamer, so which can be triggered through an Apache Spark job, where it will be continuously running and push those changes to a Hudi table, right? Again, this Hudi table you can mount it to different storage engines like be it S3, be it HDFS, or any object store which supports those Hudi format, or even directly to any file system, right? Like for example, in my laptop itself, I can just store this Hudi table also. That is one sort of an architecture on the top you are seeing. The bottom architecture is specifically like I have a typical data warehouse kind of a requirement in traditional world. I want to run it on like D+1 or a D+2, like a nightly batch. I just want to take only the change data sets based on my uh, audit columns or any incremental columns to do an incremental processing. That will be pushed as a batch job on nightly basis directly to Hudi through Spark JDBC connector. So this is another option that we can do it.
This is
Any
great. So,
question?
Bala, if I can just sum it up, I guess
Yep.
we established the need that it is more, near real-time enrichment of Lakehouse for whatever a plethora of use cases that are out there today, which are very valid and very important. So I guess we are tapping into the CDC functionality of Yugabyte. So the mapping between the wall files and Kafka topics, it's all handled seamlessly, but essentially the change data is captured from Yugabyte, pushed to Kafka in real time. And obviously from Kafka, there are many ways, and one of the ways is to use whatever you're going to demonstrate to populate a Hudi table, and wherever the lakehouse is, S3, HDFS, doesn't matter at the time.
Right.
Terrific.
That's right, Prasad. Yep, thanks. Sure.
I'll also keep an eye if there are any questions, but yeah, please proceed with the demo.
Sure, thank you. So let me go to the demo now. So let me first just to go back to the demo. Before that, I will just rephrase. So I'm just going to showcase the real-time stream use case, like how I am going to just push the data from Yugabyte directly to Hudi. So for that, I will just show my screen. So let me just come out of this. Yeah, so hope my screen is visible. I will just zoom it a bit, so in case if you are not able to see.
On my laptop, yeah, it looks good.
All right. So this is my Yugabyte 2.19.3, which I installed on my laptop. So I'm just going to connect Yugabyte. So with my Yugabyte YSQL command shell, I'm just connecting here. So I'm going to use one of the table in Yugabyte in a demo database. Say this is my database. Like I'm just typing it demo. And one of the table which I already created, I'm just showing it to you, like this is CDC test. So just showing it here. So CDC test has just two columns, a serial number and a name. So these two are the two columns are there. So what I'm just now going to do, like I just want to first make sure that I'm going to create a change data stream ID for this table or this database. So with that, I will start do my next step of works actually, right? So I will come out of this database. So in Yugabyte, we have a YBadmin command. So where we can create a change data stream ID for a database itself. That means, let's say you have all the tables, let's say 100 plus tables, and you want to create a change data stream for this entire database. You can just use this command YBadmin master address with that IP address where your leader master is running. Then this is the command create change data stream, and this is a database, which is again YSQL is our API, demo is a database name. Implicit all is going to take care of, like we have in CDC in DBCM supporting, is before and after. I'm going to show that with an example also, why before and after is important in a change data stream, because whatever I'm doing in update, I want to see the previous value what I inserted, right? That's where this is in one of the things where we have to do a before image option also, we can do that. So let's say now I'm just going to create this. So let's say this stream ID is ready. Let me just run this. Yeah, so I just run my IP address. So this is my IP address is there. Now I will just create the change data stream. So I'm just going to create it. So as you can see, this change data stream ID is now ready. So what I'm going to next step I'm going to use is, so now I'm going to take this stream ID and I need to use my Kafka connector as per the architecture. But before that, I have to set of the CDC engines and other thing. So for that, what we already have, if you look at, so we have captured already a packaged a Docker container, which is helping you to quickly run a CDC set of components are required for your organization. So we have a CDC examples. So in that, if you please go there, CDC quick start connect. So we are packaged in a Docker compose. So where it has already has the Zookeeper, the Confluent server, and all those necessary the Confluent components, the enterprise control center, and everything. So including the Yugabyte DBCM connector. So it is all pre-packaged.
Just a reminder, we have about 4 or 5 minutes.
Sure.
Just want to be.
Yeah, definitely. So I'm just not going to do this running anyway. So I'm just going to say, like, this container is already running. I'm just going to show it here. So if you just run the Docker compose up, so this Docker is all going to run now. So let me just run that command. So if you look at it, right, so it is just going to, So it's just going to show all my containers or whatever I just shown on the other screen is all going to run here. So now everything is ready for me to do my real-time streaming. So I have my Kafka Connect, I have my Kafka, everything is running. So the next stop is I'm just going to submit a Kafka Connect to see like whether I'm able to push my changes. So for that, I will just log into my database. So again, I will just log in there. I'm just going to some record. So directly. So I'm just going to the demo database. I'm going to insert into the table. So I'm just saying values YFTT, right? As a value, I'm just inserting the record, right? So now I'm just going to insert the data. So let's see the data is inserted into the database. Let's go and check whether Kafka is able to stream the data. So I will just show it here actually. So let me refresh this message. As soon as you see this is a Confluent control center, let me refresh the screen. So you can see that this message viewer is already being created. So I'm just using the same topic here. So where you can see the message viewer is now going to bring me the changes like whatever I just did it from the DB. So let's see here, right?
Bala, while you are
Yeah.
bringing that up, I think for the folks who have joined the session, if you have any questions, I've seen a couple pop up. Please, post it on the comment or chat box, and we'll pick it up.
Sure. Yeah, please. Any questions? I will wait for that. So, yeah, I inserted a second record. So now you see, now this will come here. So as soon as you see these messages are coming here, so that means you can see that, yeah. So I just entered the YFTT demo as a value. You can see my console. So it is popping up immediately here. Now my job is like it is I'm able to push the changes from Yugabyte to Kafka on this Confluent with this topic. My next job is how I'm going to bring this data to Hudi, right? So that's my next job. So for that, you already know like Hudi supports two types of table formats. So for that, what I'm just going to do that this is a simple Spark job. So what I did in my local is I already installed my Hudi what do you call the 14 version 0.14 version. I'm just using that package and I'm running my Spark in my local. I'm not building any cluster here, and this is a jar I'm referring where I want to put the Hudi delta streamer, because this delta streamer is going to be the one which is bringing my changes from Kafka to the Hudi table. So where it is going to help me to write the table in the format like either it can be a copy on write or it can be a merge on read, right? I can use either one of the table. So the rest of the properties are going to be same, like what is the source class, what is the Postgres Debezium source which I'm using it, and then again which
Yeah, Bala, let's
location
just
I'm going.
only a couple of minutes. I think
Sure,
I think we can speed up. Yeah.
sure. I will straight away go and show
Yeah.
the yeah. So with that, I think if we you can just run this command. So if you just quickly run it, so I will just show you like what exactly this is happening. So let me just run that. Yeah, I'm just submitting it.
Great. So this is the part where the change data that is now sitting in Kafka topic is pushed over to Apache Hudi.
Exactly. So as you can see now, this is the location I put it. So whatever I just tested the data, you can see here this screen. So where this is my Hudi location. So if I just show the Hudi location here, so this is the place where I want my Hudi table to be stored. You can see the like whatever I tested, and you can see the right side. I'm just querying my Hudi table also, right? So this is the Hudi table whatever I created. So with that, with the Spark, I'm just saying that where I have to load my table, the Hudi table, right? So I just loaded from here. On the left side, you can see this is the location I'm referring my Hudi table. I'm directly querying it and I'm able to see my changes, like whether this is updated or created from Yugabyte. And this is
Yeah.
really helping me to take care of the changes seamlessly, right? So
Yeah.
that's all,
Terrific.
Prasad.
Oh, if you can please bring that slide back, which kind of had that
Sure.
architecture, so to speak. So I guess to sum it up, I think we don't have time perhaps to take Q&A. We can please join our community Slack if you have any questions regarding this. So, but to sum it up, I think this is going to be a very useful design or architecture where you are able to constantly enrich data over to your Lakehouse, and you're tapping into CDC functionality. Again, the cool thing about Yugabyte CDC is at any point in time you have a need for CDC. It's a matter of firing a few commands, so you're able to set up the streams and start consuming it through Kafka. So data lands in Kafka, and from there you can do obviously plenty of things. So that is what we demonstrated today. So we are hoping that this was useful, and if you have any questions for us, like I said, please join our community Slack, and we are happy to field your questions. Looking forward to the session next week. Thank you for joining.
Thank you, Prasad.
And thanks
very much.
for the wonderful session.
Thanks a lot, Prasad. Thanks, everyone.
Thanks.